Welcome to students. Today we discuss about steps in FEA. In general FEM procedure, the solution of a general continuum problem by the finite element method follows an orderly step-by-step procedure with reference to the static structural problem. The step-by-step procedure is: in first step, discretize of given continuum. Step 2, selection of displacement model. Step 3 is the derivation of element matrices and load vectors. Step 4 is assemble of elemental equations to obtain global equilibrium equations. And step 6 to determine the unknown parameters. So today we discuss one by one steps. How can the FEM help the design engineer? The FEM offers many important advantages to design engineer. Easily applied to complex irregular shape objects composed of several different materials and having complex boundary conditions. Applicable to steady state, time dependent and eigenvalue problems. Applicable to linear and non-linear problems. One method can solve a wide variety of problems, including problems in a solid mechanics, fluid mechanics, chemical reactions, electromagnetics, biomechanics, heat transfers, and acoustic, to name a few. In simulation, using the FEM also offers important business advantage to the design organization. So, to reduce testing and redesign cost, thereby shortening the product development time. Identify issues in designs before tooling is committed. Refine components before dependencies to other components prohibit changes. Optimize performance before prototyping. Discover design problems before litigations. Now, this is the basic steps involved in FEA. These are the very basic steps and pages involved in FEA. Like first step is discretization. Second step is selection of approximation of functions. Third, formation of elemental stiffness matrix. Formation of total stiffness matrix. Formation of element loading matrix, formation of total loading matrix, formation of overall equilibrium equation, implementation of boundary conditions, calculation of unknown nodal displacement, calculation of stresses and strains. Now there are pages. These are the 3 pages like pre-processing, solution and post-processing. Here, a finite mesh is developed to divide the given geometry into subdomains for mathematical analysis, and the material properties are applied and also the boundary conditions. In solution, in this page governing matrix equation are derived and the solution for the primary quantities is generated. In post-processing, in the last page, checking of the validity of the solution generated, examination of the values of primary quantities such as displacement and stresses, errors involved is carried out. Now we discuss about advantages of FEA. It can readily handle complex geometry. It can handle complex analysis types like vibration, heat transfer, fluids. It can handle complex loading like node-based loading (point loads), element-based loading like pressure, thermal, inertial forces. Third is time or frequency dependent loading. It can handle complex restraints. Intermediate structure can be analyzed. It can handle bodies comprised of non-homogeneous materials, can handle bodies comprised of non-isotropic materials, orthotropic and anisotropic. Special material effects are handled such as temperature dependent properties, plasticity, creep and swelling. Now disadvantages of FEA. A specific numerical result is obtained for a specific problem. The FEM is applied to an approximation of the mathematical model of a system, the source of so-called inherited errors. Experience and judgment are needed in order to construct a good finite element model. A powerful computer and reliable FEM software are essential. Input and output data may be large and tedious to prepare and interpret. Numerical errors such as the limitations of the number of significant digits, rounding off occur very often. Fluid elements like boundaries at infinity can be compounded and treated by using boundary element method. Software packages for FEA is ANSYS, Nastran, Patran, NISA, LS, Dyna, Hypermesh, CATIA, ProE, SolidWorks, Cosmos. So, thanks all of you.